Today I'm diving into two key concepts, lapse rate and temperature inversion. Buckle up, because understanding these can make all the difference in aviation. First off, let's tackle the lapse rate. The lapse rate is the rate at which air temperature decreases with an increase in altitude. On average, for every 1,000 feet you climb, the temperature drops about 3.5 degrees Fahrenheit or 2 degrees Celsius. This is known as the standard lapse rate. Now, why does this matter? Well, the lapse rate impacts aircraft performance. Cooler air at higher altitudes is denser, which can affect lift, engine performance and fuel efficiency. Not to mention it plays a role in weather patterns, which pilots need to understand for safe flying. But it gets more interesting. Not all lapse rates are the same. We have the dry adiabatic lapse rate and the moist adiabatic lapse rate. The dry rate applies when the air is unsaturated, about 5.5 degrees Fahrenheit per 1,000 feet. The moist rate kicks in when the air is saturated, around 3.3 degrees Fahrenheit per 1,000 feet. Knowing which rate applies helps pilots predict cloud formation and turbulence. Alright, moving on to temperature inversion. Usually, as you go higher, it gets colder, but with a temperature inversion, the opposite happens. The air temperature increases with altitude. This often occurs at night when the ground cools rapidly and the air above it stays warm. So why should pilots care about inversions? They can trap pollutants and create smoother flying conditions below the inversion layer, but can also lead to reduced visibility and potential turbulence at the inversion boundary. Understanding inversions can help pilots make better decisions about altitude and route planning. Inversions also have a significant impact on weather. They can suppress cloud formation and lead to clearer skies, which sounds great, but can also mean poor air quality due to trapped pollutants. So always keep an eye on those weather reports. So there you have it. Lapse rates and temperature inversions are crucial for understanding how temperature affects flight. Mastering these concepts can greatly improve your aviation knowledge and safety. Until next time, keep your wings level and your mind curious.